Hi guys, so I got a quick update here what I've been working on. So I got two inputs, 24 volts each. They are kind of funny because this one was at 26.5 earlier and it's went up a little bit. That's just how batteries are. Put them under load sometimes and the voltage will drop and it'll increase a little bit. But here's the currents going in. They're pretty close to the same. This one jumps around a little bit, but it's still pretty stable. This gives a really good average of what's going on here. So I've pulled 23 watts out in almost 6 hours, 5 hours, 48 minutes. And this one's pulling a little more than this side is. This one's at 20 watts. The same amount of time, 5 hours, 50 minutes. But you can see the meters are right on the money. They're both reading the same. That one's somewhere around in between 130 to 150. And that's about what you're seeing here too. You see it on the second line right here. And this is the other one here. It's reading anywhere from like probably 140 to 190. So it gives a pretty good average of what's happening. They're pretty matched. And so what I've done here is I've fully charged this battery conventionally, normal battery charger. Wait for always wants to talk when I'm talking charge controller. But so what I've done, I've charged this completely with conventional battery charger, actually with my battery analyzer. So it was completely topped up, and then I discharged it to 12.35 volts at 0.6 of an amp, and that gave me just like 2.5 amp hours out of it, so it equaled somewhere around 30.6 watts is what I've taken out of the battery so far. And here you can see the battery voltage is right there, and that's the capacitor voltage. And you can see here now, instead of like, I don't think I posted a video of how it was before, but it was giving 10 amp pulse about every 10 seconds before. And I might still post a video, I might put a clip in with this one of that test. But with that test, I was getting about a third of the power back into the battery. I think it was actually, I think it was 7 watts out of each input battery, so 14 watts in, running the load, same speed, everything you see here. And I got 4.4 watts into the battery here. But it was one of these batteries, so it was a couple volts higher than what this battery is. But pretty much the same test, just with a LiPo battery, which is a lot more efficient than with this battery. And with the conventional battery charger, it takes close to 50 watts to charge it fully, and I get 30 to 32 watts out. And it kind of depends on the temperature of the battery quite a bit, but right now it's at room temperature, 25 Celsius. But as I was saying before, I only was getting a third of the power out with the 10 amp pulses every 10 seconds, but here now you can see it's getting about 1.5 amps, probably like every 1.5 seconds or so, or 1 second, pretty close. Yeah, it's pretty close to every second it's pulsing. You can see on my camera. And it's not even close to getting all the energy back, because I can see right here, right now, I've got 24 watts in on this side and 21 on that side. So I got 45 watts into the motor so far, and I don't think I would have, I don't know, just going by that voltage, I'd probably maybe have 25 watts into this battery. But I won't know until I do the real test of discharging it again on the analyzer. But the motor is going pretty fast and it has a lot of power. It definitely has pretty good wind there blowing, and there's some torque. And in case you guys don't know, the outputs of the motor are paralleled to the cap bank, and this cap bank is parallel with that cap, and the outputs are powering this circuit. The power for this circuit comes from the caps, which pulses the MOSFET. And all I need to do to change the pulse rate, the duty cycle and frequency, is change this cap right here. Put this one in to this one. And another thing too, if anybody's ever building one of these circuits that I've posted in the past, I posted it with two 50K potentiometers here. That's what this one is using actually. But a lot of time with these pods, they're not really perfect. Like when you get down in some areas, there the resistance is off. Like it jumps around quite a bit. So what I've done with these newer ones that I've, like say with this one here, is I put a 5K pot right here instead of the other 50K one. That just makes it so much easier to fine tune it. You can see here, this one's pulsing. I'll just change it. Just turn it up. You can see it'll stay on longer. See how it's trying to stay on. If this was a larger cop bank, you would see it stay up here longer and then come down slowly till it falls. But because it's a smaller cop bank, the cop bank drains quickly, and then what you see is the transformer putting the charge when it's hovering right at the bottom there. But you can see here, all I need to do is move this back, and then I can get it to where it's just a really quick pulse pretty easily. But with the 50K one, it's not so easy to do it. To get it to just give a real quick pulse takes some fine tuning. See, I got it pretty easily. Can turn down a bit more yet. There, it's pretty good. You get some really sharp pulses with that circuit. See how fast it's turning on and off now? It's a lot easier to tune with the 5K. So yeah, hope that helps. Sorry for the long video, boring video guys, but just wanted to do an update. And thanks for watching as always, appreciate it guys.